Alright, so for the second question, we have the anagram checking question. So we're given two strings S and T, and we're going to return true if the two strings are anagrams of each other. Otherwise, we're going to return false. And there's a description saying that an anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. So race car or car and car race are anagrams because if you count the number of R's or A's or C's or whatever is the same in these two words. By the way, like these could mean nothing, like it seems like. But jar and jam actually are not anagrams because there's M here, but there's R here. So first of all, we're gonna check the marginal cases or like the edge cases. So obviously, if the length of the two uh, strings are not the same, we should return false. So we're going to check if the length of S is not equal to length of T. We're going to return false. And otherwise, we're going to solve the problem. Right, so technically, there's so many ways that you can solve this problem. So um, the first thing that comes to mind obviously is always brute force. So we're gonna count the number of like each character in each string, and if that's true for like if the counts of each character in the string for both the strings are the same, we're gonna return true. So we're gonna define we're gonna go over the characters for char in S if S dot count. Okay, so I'm gonna explain later what I'm doing right now. Is not equal to t dot count character return false return true. Let me see if that works. Alright, that works. Alright, so the thing is what I'm doing right now is I'm just considering each character at a time. So I'm gonna go for example R in S starting with R. I'm just gonna count like how many R's are there in the S string, and then I'm gonna count the number of R's in the T, and if they're not the same, I'm gonna return false. But if they're the same, I'm gonna move on to the next character, which is A here. So I'm gonna count the number of A's in S and T, and if they're not the same, I'm gonna return false. So this is gonna terminate, and we're gonna return false as soon as the counts of a character is not similar in either of these two strings. But the thing is, like the count method, which is built in Python, is going to traverse over the string um, and like once. So we have one loop here, and we also have another loop here. So it's actually n squared. So the time complexity of this algorithm is n squared. By the way, we're checking like R's a couple of times, like A's a couple of times, for example, in this case. So many of these calculations are technically redundant. So this is actually n squared. We can solve this in n log n. So the way to achieve this is by saying that technically sorting the strings. So we're gonna say s dot sort, also t dot sort. So the thing is, these two should be the same. If s is not equal to t, return false, otherwise return true. happening here? All right, it seems like we just ran into a problem. Uh, we just need to check the sorted version of S and T. So we're gonna check sorted of S is equal to sorted of T. Return false, otherwise return true. The problem with the sort method, like theta sort, is that is a method, and then we have to specify the key using lambda function. But anyways, so you can see it works right now. But sorted, like as you know in Python, is actually n log n. So we can solve this in linear time too. But the way to achieve that is by hash tables technically. So we're gonna define a set. Technically, we're gonna call it S, and then we can also go for like at least two. Let's go for a list right now, and then we're gonna multiply it by 26 because, as you know, there are 26 letters in the English alphabet. So what we're gonna do? So here S is actually 26 zeros. Is just a list with 26 zeros. And then, for example, we're just going to count how many A's are there, and then how many B's are there, how many C's are there. So, for example, in this one, we have two A's. So the first, or the zeros index of this list should be 2. Or, for example, we have two C's. The third, or like index number 2, should be 2 as well. So, you get the idea. So what we're going to do is that there's a keyword in Python called ORD, which is going to return the Unicode of um, each character. So for example, if I print like ORD of A, it's gonna return like a Unicode, for example, like 41 something. I'm not sure, but anyways. So what I'm gonna do right now is traverse through the characters of S. So for char in S. I'm gonna add technically. Um, so what's the all right? So what should be here? So I'm gonna say the Unicode of this minus the Unicode of A. So if this is 0, this means that this character is A. If this is 1, this means that this character is B, and so on and so forth. And we're gonna say, all right, if for all right, so what I'm gonna do is go over all the characters in S, and then if there's an R, add a 1 to the index of where R is in the like English alphabet. And then if I encounter an A, I'm gonna add a 1 to in the first place. I'm gonna do the reverse thing for S, but in this case, sorry, this is the same as, I'm gonna call it my list. But what happens here is that we're gonna do the same thing with T, but this time minus. So what I'm gonna do right now is just going over S and then adding 1, like each time I encounter a character. and then subtracting subtracting one if I encounter the same character. So ideally, if these two words are anagram, we should get again all zeros, 26 zeros, right? So sorry guys. So we're gonna return true if all of these equal 0 for C in my list. If all of them are 0, these are anagram, otherwise they're not. So this actually runs in constant time. Sorry, I mean constant time. I mean linear time, because we're just traversing the characters just once. We can actually optimize it a little bit more, but you can just tweak it a little bit. So this is one, like 1n, this is another one, this is gonna be 2n. So this is just c times n, which is just n. So yeah, we showed that we can actually solve this in linear time too.